All right, welcome to Unit 3, Exponents and Radicals. So we're going to start off again. It's going to feel a little bit boring, this whole start of Unit 3, because it's essentially a recap of a recap. Like we looked at exponent rules in our previous units, we're going to do it again a little bit more formally. I'm going to move kind of quickly through the very beginning part so that we can get to the good stuff, okay? So let me switch over to my notes. And let's do this. And actually, I want you to kind of throw out some ideas, you know, let's get our, you know, our energy up and kind of work through this together. Okay, so for this first one, if we're going to apply the product rule, what is x to the second times x to the third? Go ahead and shout it out.
X to the fifth.
Yes, x to the fifth. Keep the base, add the powers. Very nice. Next, we have 5x to the second y to the first times negative 3x to the fourth y to the second. Someone else, would you like to take part B? What does this become when you multiply? So not Phil, someone else. Okay, I'm gonna call on you. Let's go with Princess. When we multiply, she's like, damn you. When we multiply here, what do we get? What's the first thing we can multiply? What do you think? Talk me through it.
The numbers.
Yeah, absolutely. So Princess is saying, let's multiply these numbers, the coefficients. So we've got 5 times a negative 3, which is negative 15. Very cool. Now, Princess, when you take x to the second and you multiply it by x to the fourth, what do you get?
8.
Keep the base, add the powers. So x to the
6.
Yes. And then with our y's, we get y to what power?
3.
Yes, 3. Good. We have 1 y here, 2 more here. Keep the base, add the power. So I'm going to make that note. Keep the base, add the powers. I won't pick on you anymore, Princess. I'm sorry. That was one and done. We're good. We're good. We're good. Next, quotient rule for exponents. Notice that we talked about this before. You keep the base, subtract the powers, leave it where it's heaviest. So let's start with Senor James Wilson. If we have x to the fifth over x to the second, how many would we be left with and where?
X to the third. Up top is where it's heaviest.
Yes, absolutely. So it's exactly where it's going to be left.
Okay. Yeah.
We could write, technically, we could write over 1, but I'm going to suggest that we leave it as a whole quantity and we don't write over 1, only because Lumen will take off points. It'll take off points if you write over 1. Cristina, for part B, how many would we be left with and where? I have x to the first over x to the fourth. So what am I left with?
X to the fourth. It'll be left on the bottom.
Oh, you're so close. You're right. It will be left on the bottom.
Oh, x to the wait, we subtract it, right?
Yes. Yeah.
Oh, so x to the third.
Yes.
That's up on the bottom.
Perfect. We're left with x to the third in the denominator, which means we do need a placeholder in the numerator. So we're going to write our answer as 1 over x to the third. Thank you, Christina. Jose, for part C, we have a lot going on here. So would you be so kind as to kind of walk us through how you simplify this?
That will be 10.
So you're looking at these coefficients?
Yeah.
Let me write this out really quickly. We actually have a fraction. How do you reduce a fraction?
Oh.
What will
So
we
that
do?
will be 3.
Ah, okay.
Negative 3.
So where's the 3 going to go? In the numerator or denominator?
Denominator.
Yes. So far, we're going to have a negative 1/3. So what I might do down here is I might actually just show that becomes a 1 and that becomes a 3. In terms of your x's, what would you have left and where?
In denominator, we have 1x.
Perfect. And what about your y's?
Y's will be 2.
And where?
And denominator we have 3, so that will be in next to 1, -1, y to the second.
Yes, perfect. So notice what Jose is saying. We have 5 y's in the numerator, but only 3 in the denominator. So we have to subtract these powers and leave it where it's heavier. It's definitely heavier up top in the numerator. So we are left with y to the second up top. Good. That's it. That you're completely done with that. Perfect. Thank you so much, Jose. Next, we have the 0 exponent rule, which essentially means that anything raised to the 0th power is 1, right? Except for 0 raised to the 0. That's something we need to keep in mind. Notice here I have x to the 5th divided by x to the 5th. Well, that's 1, right? They completely cancel, they completely divide out. And then by the quotient rule, x to the 5th over x to the 5th is the same as x to the 5 minus 5, which is the same as x to the 0. So if that's the case, it must also mean that x to the 0th power is 1, okay? It's just kind of showing you how we derive that 0 in the exponent. All right, I'm gonna start off. X to the 0 is 1. For part B, let's go Didier, 3x to the 0. What's this gonna leave us with?
3.
Yes, that's exactly correct. It's 3 times 1, which is just 3. Very nice. Okay, let's go with Nung. Actually, no, not yet. Not yet. I'm going to do part C. -5x, everything raised to the 0th power is just 1. I'm going to take the ones that are like really quick. For part D, let's go. Oh, Tiana, what about for part D? What happens here? I'm going to move this down just a touch.
I'm not sure.
Okay, quick question. What's anything to the 0th power?
1.
Oh, 1.
Ah, okay. So this part, I don't know why I'm writing a slash here. Let's get rid of that. So this part is just 1, but we have a -6 in front. So if we bring that down, our answer for part D is -6. Okay. Take a look at part E. Notice that -7 is being raised to the 0th power. What we learned in 098 in my class last semester was that anytime we have a base with a power, we want to circle it just so that it's clear what's actually being raised to that power. So I want you to circle -7 to the 0th power. I want you to circle that because only the -7 is being raised to the 0th power. Well, anything to the 0 is 1, except for base 0. And there's a negative sign in front of this expression. So I'm going to bring that negative sign down, and my answer is -1. For this last one, who can tell me the answer? What does this become?
Is it 1?
Yes, yes, it is. So it looks absolutely insane, but the entire expression is being raised to the 1st power. We know confidently that this is going to be 1 because if we simplified inside, we would have 8, right? Then we'd have a -8, and then we'd raise it to the 4th power. So -8 times itself 4 times. And then we'd square that, and then we'd raise it to the 0th power, which means it becomes a 1. All that for nothing. Good. In this side box, just be very aware. 2 to the 0 is 1, yes. 2 to the 0 is 0, no. And then 3 times x to the 0 equals 1, that's not true because only the x is being raised to the 0th power. So that implies 3 times 1, which means this should actually be 3. Okay, that's how we do this. Any questions on the review of exponent rules? There are a couple more, so I'm sure we're about to see that. Let's turn the page. Next, we have the power rule, excuse me. The power rule simply means you're going to take your power and multiply, okay? So power times power. That's what I want you to think when you see the power rule. So notice my exponent on the outside is a 2. And notice my exponent on the inside is a 3. So 2 to the 3rd squared is the same as 2 to the 6th. This is the only time you're going to multiply your powers. Now, if we take a look at part A, we have 2 to the 1st. Every base has a power. X to the 1st, y to the 3rd, and the entire expression raised to the 4th power. Power times power. I want you to hear that in your mind. Power times power. All we have to do is distribute the power throughout. So this becomes 2 to the 4th power, x to the 4th power, and y to the 12th power. Okay, I just want to use the exponent rule here, but then I will comment that you should evaluate whenever possible. So for instance, 2 to the 4th, we can evaluate. 2 times 2 times 2 times 2, that's 16. So 16, x to the 4th, y to the 12th. That's your final answer. Now I want you to notice the difference between part A and part B. In part A, you have an expression raised to the 4th power. In part B, you do not. Part B says 2 to the 1st, x to the 3rd, y to the 3rd times y to the 4th. Oh, this is not the power rule. This is actually the product rule. The product rule says keep the base, add the powers. So my final answer here is going to be 2, x to the 3rd, y to the 7th. Keep the base, add the powers. If we apply the power rule to fractions, it's the exact same thing. All you have to do is multiply power times power, regardless of where your base is. So for instance, we have 3 to the 1st over 5 to the 1st, and the entire thing is being squared. So we're going to distribute the power. So this becomes 3 to the 2nd power over 5 to the 2nd power, which obviously can be evaluated. This becomes 9 over 25. Applying the power rule to fractions is no big deal. Just go power times power. So let's go ahead and write that this is 2 to the 1st power. Nung, would you distribute that 3 on the outside and tell us what we have? Oh, you're on mute.
2 to the 3rd power.
Beautiful.
And then is it x to the 6th power?
Yeah, perfect. Very, very nice. We're just going to distribute power times power. So even though we had a base in the denominator, that idea doesn't change. No big deal. Power times power. 2 to the 3rd, 2 times 2 times 2 is 8. So we'll write 8 over x to the 6th power. Didier, what about part B? We have x to the 4th over y to the 3rd, and we're going to square it. What does this leave us with?
X to the 6th.
Ooh, what are we going to do with these powers?
We're going to add the powers. So.
No, not add, but multiply. So power, yeah, power times power. So it's going to be x to what?
The 6th.
No, multiply these?
Yes. No, to the 8th.
Yes, beautiful. Over?
It's going to be y to the 6th now.
Perfect. Yes, beautiful. Power times power. So I'm just going to power multiplied by power. Perfect. Very nice. Expanded power rule. It doesn't matter how many bases you have in the set of parentheses, you're still going to do the exact same thing. So let me show you. So here we have 4 to the first, a to the second over y to the first. This is all being raised to the third power. So remember, you're just going to distribute power times power. This becomes 4 to the third, a to the sixth, all over y to the third. We're obviously going to simplify 4 to the third. So 4 times 4 times 4. That's going to be 64, a to the sixth over y to the third, and you're done. For example 6, there's a couple things that we're going to have to do. And the first thing is we want to simplify inside the set of parentheses first. So is Jimmy with us? Jimmy, you're with us, right?
Yeah.
Okay, score. What would you simplify inside here first? What can you do?
Probably the well, I mean, I would first simplify. It's like if there's any whole numbers, see if they would go down into each other or simplify.
So what number can you divide out of both?
9.
Yes. Yes. Yeah. Beautiful. Okay. So if we divide each of these by 9, what does that become?
I think it's 4 over 3.
Okay. Very nice. How many x's would you have left and where?
You would do x and up x in the numerator. 4.
Perfect. And how many y's would you have left and where?
Would it be y1 in the denominator?
Yes, perfection. Very nice. Thank you so much, Jimmy.
Yeah.
Once he simplified inside the set of parentheses, by the way, keep in mind the idea of PEMDAS, right? So you want to take care of what's inside parentheses first, which is why we do this, to make our lives easier. Let me move this down a touch. So we simplified inside the set of parentheses before we ever apply that exponent on the outside. So now we just have to finish this off. Summer, are you with us? Would you be able to apply the power rule to this expression? What do you get?
Yeah, but I do really struggle with this, so I guess bear with me. I'm still pretty confused.
No worries, no worries. I got you.
So the in the parentheses first?
Well, so this is actually, we're actually good here. What we want to do now is we want to apply this exponent of 2. So think back to what we did with a problem that only had these bases. We always did power times power. So essentially what we did, Summer, is we just distribute the power to every power in the parentheses.
Okay, and not the numbers.
No, never the numbers, just the power.
Okay.
Power times power.
Okay, so I guess it would be 4, 2.
Yep.
And then x8 over 3, 1. 3, 2, y2.
Yes, perfect. So we distribute, and it helps to kind of draw the lines of distribution. I'm just going to draw them lightly so you can see that you're multiplying power times power. And yes, Summer, that's exactly correct. So by distributing those powers, we can now simplify further. 4 to the second power, 4 times 4 is 16. And then 3 to the second power, 3 times 3 is 9. And there is your final simplified form. Thank you so much, Summer. That was perfect.
You're welcome.
All right. I think the key here to remember is you want to clean up inside the parentheses first, if you can, before you apply the exponents. We have one more rule, and that is the negative exponent rule. Let me lift this up so you can see. All it says is you essentially will move the base with a negative power. So just to show you, by definition, y to the second over y to the fifth, by definition, is y to the 2 minus 5, which gives you y to the negative 3, right? But we recall that if we were to just say, well, what would you have left and where? You would tell me you'd have y to the third in the denominator. So that means that y to the negative third must be rewritten as 1 over y to the third. So these two are synonymous. They mean the same thing. Okay. So we don't have to worry. This is essentially the same thing. Okay.
How about the negative sign?
So by taking this base with the negative power and moving it to the denominator, that's what changes the power from negative to positive. That act of moving changes it. So for instance, if I had 1 over y to the negative 3, I would take that base with a negative power and I'd move it to the numerator. As soon as I did that, it would become a positive exponent. Does that help, Jose?
Yeah, thank you.
You're welcome. Let's look at this box over here. A negative 2x to the negative third is not the same as 1 over 2x to the third. Reason being, the only base being raised to the negative power is that x. So technically, what this should become is a negative 2 over x to the third. That's actually how you would rewrite that. Yes or no? Is this first expression correct?
Yes.
Yes. We took that 2, raised to the negative 3, we move it to the denominator, and then that power becomes positive. Perfect. Yes or no on my second expression?
No.
No, absolutely not. This is just crazy. This, I don't even know where this comes from. Yes or no on my third expression?
No.
No.
No. So yes to moving that 2 to the third to the bottom, but what? Where did that come from? I'm gonna put a question mark here because I'm like so confused. Where did this negative come from? That makes no sense. And then of course, negative 2 is not the same as 1/2. No, 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 never, never. Okay, good, cool. Let's just apply the negative exponent rules real quick because it's really not a big deal. Circle the base with the negative power. We have a y to the negative third. This moves to the denominator. So this becomes 1 over y to the positive third. In our second expression, b, what's being raised to a negative exponent? Go ahead and shout out.
The y.
Just the y. Thank you so much. So where is this going to go?
Up.
Yep. Let's move it up to the numerator. We have a 1 there already, so we could write 1y to the second power. It's going to be positive over negative 3, but that's super ugly. So we want to bring the negative in front of the fraction or in the numerator. So I'm going to write negative 1y squared over 3. That's a much better way of expressing that answer. Don't leave the negative in the denominator. All right, someone else for part C, what is being raised to a negative exponent? Don't be shy. What's being raised to a negative power?
3.
Yes, okay. 3 is being raised to the negative 1, so where would that go?
Down.
Yes, which means the 2 is still in the numerator. So this becomes 2 over 3 to the first power, which is just 3. Perfect. Then we have a plus. Thank you, Jose. Someone else. What else is being raised to a negative exponent?
The 4.
Yes, the 4. So we have 4 to the negative 2. Where is this going to go? Where is that going to go?
That will be 1 over 4.
1 over 4 squared. So
Oh.
4 to the negative 2 is the same as 1 over 4 squared, and 4 squared is 16. Interesting. Now that we've actually cleaned up these negative exponents, we can now add fractions. What do I need if I add fractions? Shout it out. You all know this.
LCD.
Yeah, cool. And I'm not going to worry about that. You know how to add 2/3 and 1/16. Cool. For part D, what's being raised to a power?
-4.
It would be if it looked like
Just
part
4.
D. Yes, just the 4. Now this is crazy. I'm going to rewrite this because that's mad small. So I'm actually going to white it out and rewrite it. What D said was this, -4 squared. The only issue is, look at the difference between part D and part E. Part D, we don't have parentheses. Part E, we do. So in this first case, the only thing being raised to that power of 2 is actually the 4, which is why I like us to circle the base with the power. I feel like it's helpful. I feel like it draws our eyes in and we're not distracted by everything else that's on the outside. So for part D, this actually becomes a -16. For part E, the entire quantity is being squared. So -4 times -4, that's essentially what this becomes, -4 times -4, because you're squaring the contents of the parentheses. So that means part E is a +16. What's being squared in part F?
-4.
Just the -4, very nice. So just this part, whoop, that's being raised to the second power. So -4 times a -4, well, that's a +16, but we have a negative sign in front. So we're going to bring that negative sign right down. And your answer becomes -16. Okay. Very cool. We're going to be able to get through these 6, and that will probably end our first session of the day. Who would like to take part A? Tell me what this becomes.
1 over x to the second.
Yes, very nice. Jose took part A, so she's done. Someone else take part B.
4x to the third.
Yes, Shane takes this because x to the -3rd will move up to the numerator, and he knows that that means it's going to be attached to 4 by multiplication. So this becomes 4x to the 3rd as your final answer. Shane, you are also all set. So Jose, Shane, you're done. Part C, someone else who would like to take this. There's a lot going on here. So be prepared to kind of talk through all your thoughts, but don't shy away from it. It's no big deal.
Well, I mean, if you're multiplying, you distribute, right?
I mean, I like what you just said about circle the negatives, because where will these go?
I'm just going to go up. Wait. I mean, wouldn't they turn into fractions eventually?
Yes. Okay, good.
Oh, I guess it would go down.
Yes. So in this first parentheses, would you be okay with me writing x to the 5th over, and instead of writing 4 squared, I write 16?
Yeah, that's fine.
Cool. So there's the first one. How would I write the second expression here, the second parentheses? How would I write it as a fraction? What's in my numerator?
Would it be I mean, you have the -6.
Yeah.
And it goes to the 8 power.
Where would this go?
Will it still stay on top?
It wouldn't, only because it has a negative exponent, so we have to
go to the bottom.
Yes. So move to the denominator. I'm just going to draw little arrows to show that they move to the
This is why I
denominator.
was at the top,
Yes.
because positive. Okay.
Perfect. Okay. So at this point, now that everything has been moved around, we don't have any negative powers. Now we can simplify. So continue. Help us simplify.
So I guess oh, damn.
If you want a partner, let me know. I can ask someone to join in with you.
Would you take the x fifth power and the x 8 power and reduce those down?
Yes. So how many would you have left and where?
So you would cancel out the 1 and the 5, and then on the bottom there would be just x3.
Yes. So this goes away. And this becomes x to the third. That's exactly correct. So right now I know I have an x to the third in the denominator.
The y2 up there.
Yes, beautiful.
What
about these? What can I do?
You could divide them.
Yes, by what number?
6.
6 won't go into 16.
3. Wait, damn. 2.
Yes. Divide both by 2. So this becomes negative.
Negative 3.
Over.
And then that'll be 8.
Done. That's your final answer. Excellent. Thank you so much, Jimmy. That was a really, really big one. Part D, would someone else take over? So not Jose, Shane, or Jimmy. Someone else. Part D. What happens?
Move the y to the -4 up.
Yes. So tell me, how do I write my answer?
3xz squared and then y to the 4th power.
Beautiful. Perfection. Very nice. And was that Christina? No, who was that?
Me.
Who said me?
Nung.
Nung, there we go. I was like, I can't see that video. I have no idea what. Okay, perfect. Thank you, Nung. Part E, who would like to take this over? We have 60 seconds left. Who can do part E? James, you want to take it?
E, you said?
James Wilson.
I would say that the I'm just gonna give you the denominator as best I can say it. The 2 A B to the 3rd. I'm sorry.
Yeah, can we start with one thing? What should I circle? What's going to move?
Okay, yeah, the -3 will move to the bottom.
With the A, correct?
Yes, with the A.
Yes. So I'm just going to draw an arrow just to show. And what else is going to move?
The D to the -5 will go up.
Yes, perfect. So now just tell me what's left. So what's in my numerator?
2B to the 3rd. And the denominator is C to the 4th.
Good. What? And now let's move these pieces. So what else is in the denominator?
A to the 3rd.
Yes. And what else is in the numerator?
D to the 5th.
And you're done. Perfection. We have no other common bases, so we're not going to be able to simplify here. Perfect. 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 Excellent work. I will be back at 12:30 to continue recording our session. So I will start off on part F. Right away, we're going to move into roots and radicals. So if you can attend, please do. We're going to talk about properties of radicals and then how to break them down, which is going to be pretty fun. Okay, so I will be back on my live stream channel at 12:30. Excellent work this morning. If you can't join me later, no big deal. The videos will be uploaded later today. All right. Bye, everyone. Ciao.
Bye.